So today we will analyze an electrical network by using the method of node analysis. So let us define what is a node. Node is a point which is common to two or more circuit elements or branches. So at node one can apply the KCL, whereas to the loop or to the mesh one can apply the KVL. So here in this particular method we have to use Kirchhoff's current law. So it states that algebraic summation of currents at a particular node is equal to 0, or incoming current is equal to outgoing current. So main objective of this particular node analysis method is to determine voltages at different nodes. And once I know the voltages at different nodes, by knowing the resistance values, I can calculate current flowing through any element. So our objective is either to find the current through some element, or voltage drop across that element, or power consumed by that element. So let us place the question like this one. For a given circuit, determine a current flowing through 4 ohm and 6 ohm resistance. That means objective of this particular problem is to find out current flowing through 4 ohm and 6 ohm by making use of node analysis method. Okay, so I will place the objective like this one. I4 is equal to how much and I6 ohm is equal to how much. So we have to follow certain steps to complete the problem. Very first step is, what are the circuit is given. So that circuitry we have to redraw properly with a proper values. Next, if we observe the circuit, then we have to determine how many nodes are there. Already I have stated, node is nothing but a point which is common to two or more elements. So if you look at the circuit, this is the battery, a voltage source of magnitude 40 volt with polarities plus and minus. But this is the resistance with value 2 ohm. Now this is a point which is common between 40 volt and 2 volt. So if I apply the definition of the node, definitely it is a node, because it is a point which is common between 40 volt and 2 ohm. But this node is not the effective node. So we have to define the term effective node. So the node at which a potential is unknown, I can call that as effective node. So here already the potential is known, 40 volt potential is known. So that's why I will not treat this as a node in my analysis. Similarly, this is the point which is common to 6 ohm and 20 volt. So this is not the effective node, since the potential at this node is 20 volt. So what are the remaining points are there? This is a point which is common between 2, 4 and 8 ohm resistances. So this is one node. So I will mark it as, say, node A. Now this is another point which is common between 4, 6 and 10 ohm. So I can call this as another node, effective node B. And if you look at this bottom line here, so this will form one common junction, one common node. I will call that as, say, node C. So first step while analyzing the circuit using node analysis method is to mark the nodes like this one, A, B, C and so on. In the next step, one node we have to take at a reference potential of 0 volt. So when I am having a node A, my voltage is VA. When I am having node B, my voltage at that node is VB. When I am having node C, the voltage at node C is VC. And this VC node I will take at a reference voltage of 0 volt. Okay, that means I am having now two unknown voltages, VA and VB. Now, as already stated, whenever there exists a node, we have to apply the KCL. Alright. So what we have to do is, at node A and at node B, we have to apply the KCL. So initially, I can take any direction of the current. Now since VA and VB are unknown, we can take the current directions like this one, and I can make the currents, write the currents like I1, I2, I3, I4 and I5. Okay. Then we have to proceed like this one. We have to apply KCL at node A. Now what is the KCL equation is there? That KCL equation at node A is, what is the KCL? Incoming current is equal to outgoing current, or total current at particular node is equal to 0. So here I1 is the current coming at node A, so I will have I1 incoming current. Now these two currents are outgoing, so incoming current is equal to outgoing current, that is I2 plus I3. This is equation number 1. Okay, now in order to find out the current, we have to recall the Ohm's law. So out of phi, I and R, if one term we have to calculate, we should know the remaining two terms. That means this I1, how to express in terms of voltage and resistance. Okay, now since I1 is flowing like this one from left to right, that means what we have assumed is this potential is higher in comparison with this one. So I1 current is 40 volt minus this 40 volt minus VA divided by this 2 ohm. So this is your I1, that is equal to. Now what is I2 then? I2 is flowing downward. That means this VA potential is greater than 0. That is the meaning. Since the current is flowing down, so it is VA minus 0 divided by 8. That is the resistance. That is I2 plus. Now I3 current is flowing from left to right again. Okay, that means here we have assumed VA potential greater than VB. So it is VA minus VB by 4. So let this be equation number 2. So here this equation we have to rearrange properly in terms of VA and VB. Okay, for example, here I am having 20 minus VA by 2, that is equal to VA by 8 plus VA by 4 minus VB by 4. So this is the same equation, so I will write this to be say 2. Now if you take the say LCM, so if I write the LCM as 8, then the equation comes out to be 160 minus 4 VA, that is equal to VA plus 2 VA minus 2 VB. Okay, so what that 8 LCM is there? That 8 LCM gets cancelled. So it is 160 minus 4 VA equal to VA plus 2 VA minus 2 VB. Now once again, if you rearrange this one, so 160 is equal to 4 plus 1, 5 plus 2. So it is 7 VA minus 2 VB. So let this be the next equation, equation number 3. Or you can write 7 VA minus 2 VB equal to 160. So this is the equation which results after application of KCL at node A. Similarly, I will apply the KCL at node B. So when we apply KCL at node B, the incoming current is I3, outgoing currents are I4 and I5. So the equation is I3 is equal to I4 plus I5. So let this be equation number 4. That means now we have to express those currents in terms of potential difference and resistance. So again, if you look at I3, so it is VA minus VB divided by 4, that is equal to I4 is the current that is flowing down, so it is VB minus 0 divided by 10 plus I5 is this current. So here potential is VB, whereas here potential is 20. So it is VB minus 20 divided by 6. So again, we have to simplify this one. Okay, so when you are so if I write this to be equation number say 5, how to simplify? So I can take the LCM say 60 for example, for simplicity. If I take the LCM 60, then this term is 15 VA minus 15 VB, that is equal to 6 VB plus 10 VB minus 200. Are you getting this one? So if you take the LCM as 60, this term is multiplied by 15. So it is 15 VA minus 15 VB. This term is multiplied by 6, so it is 6 VB. But this is multiplied by 10, so it is 10 VB minus 200. So if you again rearrange this equation, so VA term is just 15 VA. So this 6 and 10, 16, those are coming on this side. So it is minus 31 VB is equal to minus 200. So this is equation number 6. Okay, that means what we got is equation number 3 and equation number 6. These are two equations that we obtained after applying KCL at node A and B. So what is the problem statement? What is the problem statement? To find out current flowing through 4 ohm and 6 ohm. To determine these currents, I have to calculate VA and VB. So initially, VA and VB are unknown voltages. So what I have to do is, now I have to solve these two simultaneous equations. Now choice is up to you. Either you can use the Cramer's rule or you can use a direct calculators. Okay, so when you solve these two equations, what you are getting is VA that will come to 28.66 volt. So do the calculations carefully. Whereas VB comes out to be 20.32 volt. Okay, so this is your important result. VA is 28.66 whereas VB is 20.32. The problem is not at over, because I have to calculate I4. Now if you look at resistance 4 there, so what is I4? Current flowing through 4 ohm is equal to, see this current is equal to VA minus VB by 4. So you have VA minus VB by 4. So these equations will give you VA and VB. So if I place these two values here, divided by 4, I can get the value of I4, and that value comes to be 2.08 amperes. So I4 ohm, one answer is 2.08 ampere. Now the next calculation is I6. That means I want the current flowing through 6 ohm. See, once again it is VB minus 20 by 6. So I6 ohm is equal to 20, sorry, it's a VB minus 20 divided by 6. So if you place the value of VB there, then you can calculate the current flowing through 6, that is I6 ohm is equal to, that comes out to be 0.053. So these are our final conclusions. So I will conclude the current flowing through 4 ohm and 6 ohm resistances of a given circuit using node analysis method are 2.08 ampere and 0.053 ampere. So one more point that is to be noted is the sign here is positive, here also sign is positive. It indicates that whatever the current we have assumed, this direction is correct. That means current is flowing from A to B, node A to B, whereas this current is flowing from node B to node C, that is the reference potential. If in the calculation, if you get any current negative, for example, suppose if you got I4 negative, okay, so whatever the magnitude is there is no change, magnitude remains the same. But as far as the assumed direction is there, that direction we have to change. Are you getting this one? So in summary, if the question is to determine a response of the circuit, Response stands for, say, current here. In this case, we have calculated current. Current through any element using node analysis method. Very quickly, what we have to do? We have to redraw the circuit. That is the first step. Then we have to mark the effective nodes. Let us mark as A, B, C, so on. Next step is assume the nodal voltages like VA, VB, VC, and so on. In the next step, treat one node at a reference potential of 0 volt. And for the remaining nodes, just write the KCL equations that we did. Apply the Kirchhoff's current law at node 1, node 2. Then whatever the resulting equations are there, solve those simultaneous equations. What you are getting is voltages at different nodes. And by knowing the voltages like VA and VB, you can determine the response of the circuit, that is current flowing through any element. Thank you.